Alright, number 12. I rolled the fair dice 20 times and counted how many times I got a sum of 5, and I repeated it 16 times. These are all 16. Find the mean, mode, and median. So we'll put this into the calculator to get this quickly here. So stat, edit, and I'll put them in. I'll put it in list 6 here. I've got 2, 2, 3, 0, 1, 2, 1, 5, 2, 3, 0, 2, 5, 1, 2, 2. And there's the 16th one. So stat, calc, the one variable statistics on list 6. Did I put in list 6 or 5? Let's see. That looks right. Let's just check, make sure it was list 6. Yeah. So, and I did list 6. Okay, there it is. So the mean on this is 2.0625. This is actually the exact data from the last test we had. No, it's not quite. I must have changed some numbers here. That's the mean. The median. So I need these in order to see that. Stat. Let's see. Sort list 6. So now I can go stat and look at list 6, and it goes, the numbers are 0, 0, 1, 1, 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 2, 2, 4, 5, 6, 7. Oop. 2 5s, 2 3s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's the 16. So the median would be 1, 2, 3, 4, 5, 6, 7, 8, between 8 and 9, which is 2. And the mode, the most common number was 2. There were 7 of them. Okay? Give the Tukey 5-number summary. So the min is 0. Lower quartile is, so if there's 16, it's 8. Halfway between 4 and 4, there's 1. Median we decided was 2. The upper quartile was, see, 1, 2, 3, 4. So between 2 and 3, 2.5. And the max is 5. And draw a box plot. Even scale, 0, 1, 2, 3, 4, 5. Whisker to 1, to 2 is a box, to 2.5 is a box, and then to 5 is a whisker, but there might be an outlier. See, this is 1.5. 1.5 is the interquartile range times 1.5 is 2.25. So the fence would be at 2.5 plus 2.25, 4.75. So there is an outlier, so the whisker can go to there if I want to get the extra credit. Fence. Okay. Determine the standard deviation and the value for 84, where 84% of the data is expected to be below that value. So the standard deviation was 1.39. And we could do the estimation, the range, which was 0 to 5 divided by 4 is 1.25. We could use that approximation. So the mean 2.06 plus 1 standard deviation, 1.39. Go 1 standard deviation and we get 34 plus 50 is 84%. So that score is 3.45. And that's where the standard deviation is this, and the value that we expect, the standard deviation is that, and we expect 84% of the data to be below that value of the mean plus 1 standard deviation. 15. 15. We have 16 sets of dice above and random sample. What would be the mean value for getting sums of 5s in 20 rolls based on the sample? So based on the sample, we think it's 2.0625. And our confidence interval at the 95% is that plus or minus the standard deviation of 1.39. 2 times the standard deviation divided by the square root of, we had 16. So 2 divided by 4 is half of this, so it's going to be 2.06 plus or minus, I'm going to round that down to 1.39 divided by 2 is what the margin of error is, 0.695. We could call it 0.70. This rounds to 0.70. So I'm going to go from a 70 above this, which would be 2.76, down to, take off 70, it's going to be 1.36. That's my 95% confidence interval. I believe the true answer should be somewhere in here, and 2.22 is in there, so there's no reason to reject the null hypothesis that this is it and that's it. So yeah, because it's in the confidence interval. Okay, and this says number 1, but it's really number 16, so something went wrong in my word. 2500, so the margin of error for a 2500 sample is 1 over the square root of 2500 when we're talking percentages, which is 1 over 50, I believe. Yeah, I think so. Square root, I'm getting tired, so I don't want to mess up. 50, when 1 over 50 is 0.02, or 2%. So that means the confidence interval is 47 plus or minus 2. So minus 2 is 45%, plus it is 49%. So we're 95% sure that the true population would be somewhere, the percentage in favor of gun control would be in that range. All right, that's that page.